welcome. Let's try to solve Leetcode problem 2115, but all possible recipes from given supplies. So I will not read the descriptions again and again, but I will explain what is the meaning. So for the recipes, so for example, we have bread. Let me make use the white color. So for example, we have this bread. I'm gonna use B. So we want to make this kind of a recipe bread, but we have ingredients. So our ingredients is yeast and flour. I'm gonna use Y and F. Yeah. So there is some dependencies. So in order to get this kind of a bread, we need to have this Y and F. If we have this Y and F, we can make this bread, and we're gonna return this bread. Yeah. So we have our recipes array, and we just want to check if we can return all the recipes. Yeah. So for example, for this bread and sandwich, we can return it. So we're gonna return this array. But for sometimes we cannot do that. Yeah. So in this example, the recipes we have bread, sandwich, and burger. This is our supplies, and this is the ingredients. And the first one, I mean index 0, the yeast and flour, this is for bread. And bread and meat, this is for sandwich. Yeah, we should understand. And sandwich, meat, and bread, that is for burger. So we want to check if we can make all of them. So bread, sandwich, and burger, it seems we can make all of them. But we also have another array. It is the supplies. Supplies is about what we have. Yeah. So let's start to check this example maybe. Yeah. So for Y, currently we have the supply Y, F, and B. It means yeast, flour, and meat. Yeah. So for this yeast and flour, we have yeast flour, and we can make yeah, with supplies we have meat. Let me use another one. So this is meat. This is M. So this is M. So for Y, yeast, and F, flour, we can make bread. So this is gonna be B. Yeah. So this means there's a direction Y and F connected, directed to B. And for bread and meat, for B and M, so we're gonna use B and M. We're gonna make we're gonna make the sandwich S. Yeah. And then for sandwich, meat and bread, so this is a bread, this is a sandwich, and this is a meat. Yeah. So we're gonna make another one. This is called burger. Let's use the burger. Yeah. Let me make it longer. So this is gonna be the burger. Yeah, it seems that there's a topological structure, and if we want to make the burger, we need such kind of dependencies. If we want to bread, we need the yeast and the flour. If we want to make the what is this sandwich, this is S. Yeah, if we want to make the S sandwich, we need to have the bread and the meat. If we have this kind of a structure, definitely this is going to be a topological structure, and we can use the topological sort to solve the problem. I think there's no difficulties about this problem. Basically, we need to understand that, and then we're gonna use a topological sort to solve the problem. We just need to find a topological sequence, and the topological sequence is just inside the recipes. Yeah, definitely, we're gonna get all our possible results because this is the supplies. We're gonna put the supplies inside our queue, and we're gonna check if we can make this B or S or burger, and then we just output them according to the topological sequence. Yeah. Now let's try to solve it. So we're gonna have a graph and integrate. The graph gonna be default dict with the list, and integrate gonna be 0 times I think the length of the recipes. Let me check. No, we cannot use. Yeah, I think the integrate gonna be. Yeah, there's some. We need to check the integrate carefully. Yeah, in degree we need to prepare a hash table for the integrate. Yeah, because it is not like the node from 0 to n minus 1. It is always about the string. Yeah, we need to deal with the string carefully. Let me check what should be inside the integrate. So this is our supplies. Yeah, do I even need to have this kind of integrate? I need to have this kind of integrate because I need to put everything inside the result. Maybe let me just put this kind of things inside the integrate, because definitely I want to get such kind of a sequence. Yeah, maybe it is 3, the length, maybe the length is 2. Yeah, but let's just prepare the integrate as the, yeah, let me check how can I, I'm gonna use a hash table, so the integrate gonna be, yeah, I think I'm gonna prepare the integrate later because it depended on the graph. Yeah, definitely I'm gonna prepare a default dict, and inside the key is the string, and the value is for integrates, so it's gonna be an integer. So for the integrate, now I'm gonna check the graph. So there's a connection with the recipe and the ingredients, so I need to zip them together. So for R I in zip, yeah, maybe let me just use ingredients. Yeah, because it is too short for I. R is for recipe, so for R, maybe let me make it longer. So for recipe, ingredient in zip, recipes and ingredients. Yeah. So for that inside, now I'm gonna check the ingredients, right? So for I, yeah, because the ingredients is just an array. So for I in ingredient, now I want to prepare the graph. So the dependencies is from this ingredients to the recipe. So this means for the graph, it is I should append this recipe, and for the integrate should be this yeah, because this I directed to the recipe, so the integrate recipe should plus equal to 1. Yeah, so I think this is going to be the difficult. We need to think about it a little bit. After that, it's going to be easy. It is just the template. Yeah. So for the Q, it's going to be the Q. Yeah, but what should we put inside the Q? We should put all the supplies inside the Q. Yeah, because definitely we don't need to check if this integrate going to be 0. Definitely these things cannot be 0 from the beginning. We need to put it inside of a result. Yeah. So this is a Q, and the result going to be an empty array. And now I'm going to check the Q. So while I'm checking the Q, I'm going to pop out the supplies. So it's going to be a node Q dot pop left. So for neighbor in G with this node, so the integrate with this neighbor should minus equal to 1. So if the integrate with this neighbor equal to 0, it means I need to put it inside the Q. So Q need to append with this neighbor. Finally, I need to return the result, but I didn't put anything inside of the result array yet. Where can I put it? I need to put this node. Yeah, definitely. It is this node. Yeah, let me check if what should I put it inside? It's not this not, because not is only the supplies from the beginning. But from here, if it is equal to 0, so this means I made something. Maybe it is bread or sandwich or maybe burger. It means from here, I need to put it inside my result. It means it is this neighbor. This is what I made for the recipe. Yeah, now let me run it to check. It seems everything is okay. Now let me submit it to check if it can pass. Yeah, as you can see, it works and it's pretty fast. Now let's analyze the time complexity. And because inside of the k, this is going to be a string. Let's just imagine the string is very short. Yeah. Let's analyze the time complexity by the vertices and edges. So this is the ingredients less and recipes less. So for here, this is for building the graph. So this is a for loop in zip because the length is equal to this is n, this is another n, this is n squared up to here. Now we are going to check it from here. So the time complexity for the topological sort area, it is e plus v. Let me check. So the number of vertices is 100. So what about the number of edges? Can I get some information about the number of edges? Yeah, so the ingredients I dot less and the supply dot less is also 100. This is okay. I want to check the basically I want to check the edge. So I think the edge gonna be n squared. Yeah, because it didn't mention about it, but we can calculate it according to this ingredients I dot less and the recipe dot less. Yeah, because they are equal, so it's gonna be n squared, so 100 squared. It's gonna be the topological sort time complexity. But we need to check the length of the string. The length of the string gonna be 10. Yeah. So if the length of the string gonna be 10, so the final time complexity gonna be 10 times 100 times 100. So it's gonna be 10 to the power of 5 for the time complexity. Maybe you're gonna call it k is this 10, k times n squared, and gonna be the final time complexity. Thank you for watching. See you next time. Yeah, I forget did I run it or not, but let me just submit it. Maybe I forget about it. Yeah, I think I've already submitted it. Thank you for watching. See you next time.